Hello students, welcome to first lecture of Kinematics and Theory of Machine. Myself Professor Patel from LJ Institute of Engineering and Technology. We are going to start our first chapter, Simple Mechanism, and I am going to give you total introduction of first chapter, and we will learn the kinematic links. What are the types of link and how can you count kinematic links of any mechanism? Okay, let's start. Okay, let's start with the name of our subject, KTOM, Kinematics and Theory of Machine. So, first of all, start with the kinematics of machine. To study the relative motion between the parts of machine. So, in kinematics, we study only relative motion without the considering the force or why this motion is generated. We study only and only relative motion. Okay, in relative motion we will consider position, displacement, rotation, speed, velocity and acceleration. This parameter we will study, not the force, inertia, mass. It all will be ignored. Okay, so this is a kinematics of machine. In this particular region we study the mechanisms and machines. Okay, so our second part of our subject is theory of machine. In theory of machines, we study the relative motion as well as force also. Okay, so in this case, relative motion and force both will be considered. There are two chapters in our subject. In that particular two chapter, we will consider force and motion both. Okay, so let's start with the chapter number 1, which is a simple mechanism. In simple mechanism, start with a kinematic link. We will study the kinematic link. So you can see on this is a single slider mechanism. In this single slider mechanism is a combination of lots of links. Link number this 2, this link number 2, 3 is a connecting rod. There is a other, you can say, link number 4 here, which is piston, and this is the fixed base, which is also which is link number 1. So this is the mechanism which is made by the links, different links, okay, which have relative motion to each other, and these links together makes the kinematic pair. Okay, kinematic pair. So you can see here this link number 2 and 3 connected here, so they are making the pair. 3 connected to 4 at this point, so there is a pair. So this that's how two links connected and making a pair. So in this, after that kinematic pair, we will study chain. Lots of pair combine and makes the chain, and chain, using the chain and fixing the one of that chain, one of the link, we will make the mechanism. And mechanism or number of mechanism assemble in a such a way that if that combination gives us any useful work, then it is called machine. Okay, so this is the single sided mechanism, but using that mechanism, what we will make machine. So this is a reciprocating steam engine. In that particular machine, we have used this mechanism, single sided mechanism. There are also other mechanism also used in that particular machine, like there is also there will be valves and control system. In that other mechanism also used. Okay, okay, let's start with the kinematic link or kinematic element. Each part of machine which move relative to some other is known as a kinematic link. Okay, you can see in this figure there is a reciprocating steam engine is there, lots of elements are there. So first of all, we recognize what are these elements. First of all, crankshaft, which is located here in center. Inside view you can't see, in top view you can see whole crankshaft, and there will be also bearing, and there is a crank. Okay, crank, big big end bearing, because connecting rod is a two ends, small end and big end, and both end will be connected with the bearings. Flywheel is also there, and there is a crosshead, you can see, which helps to transform the oscillating motion of connecting rod into reciprocating motion of the piston rod. Okay, there is a piston rod, cylinder, and engine frame. So these all are elements, but how many kinematic links are there? You have to understand that. First of all, you have to check what is the definition, which moves relative to some other parts. So there are some parts which have no relative motion, so we don't consider them as a kinematic link. So first of all, we have to find how many links are there. Okay, so maybe some student, lots of student has a doubt about, sir, engine frame which is totally rigidly fixed, like this cylinder also it is fixed, and this frame is, this is totally fixed, there is no motion in these parts. So it is considered, we will consider as a kinematic link. Why? So first of all, this is a relative motion, and in relative motion you have to understand that if you are in train, okay, like A, and some person is outside of this train, if this train is moving, what will happen? You feel that B is moving, but actually B is steady and you are moving in particular direction. So although B is steady, but with respect to A, B has some velocity, because it is a relative velocity we are talking about, not absolute velocity. So we what we will consider, so we, as a link number one, all fixed part we will consider as a link number one, like cylinder, this cylinder, this frame, total frame, and bearing, which all are steady, not rotating, not even moving. But due to these parts which are moving, relative to them, this part has a some relative velocity. Okay, and then start with the relative motion of crank. This crank will be the link number two. Okay, crank, crankshaft, and flywheel. Why these three elements as considered as a link number two? What I have said earlier, always remember the relative to some other part. This crank, this crankshaft, and this flywheel. If I am saying crankshaft rotating 400 rpm, then crank, crankshaft, and flywheel both are connected on, all three are together rotating at a 400 rpm. So all three moving together, so there is a no relative motion between them. Okay, so that's how link number two will be considered as all three element. Okay, then crank is connected to what? This connecting rod, and connecting rod has a two bearings also connected with them. So whatever the motion of this connecting rod will be the same as what? Both bearing. Okay, so link number three will be connecting rod, and small end bearing and big end bearing. Okay, and after that what will happen? It is connected to this crosshead, this assembly, piston, and this piston rod. So all these parts will be considered as a single element, single kinematic link, because relative motion we are talking, all parts are reciprocating together, so there is a no relative motion between them. Okay, so all will be considered as a link number 4. Piston, piston rod, crosshead will be constitute one link. So that's how all 4 link you can see. Okay, so check this out. This is our simple diagram for that mechanism. You have seen the steam engine, but it is the single slider mechanism with simple diagram. So you can see this. So link number 1 is a frame, link number 2, link number 3, and link number, this is the 4, and that's how they make this mechanism which is known as a single slider mechanism. Okay, so every time, one point I want to revise again, every time whatever mechanism we pick, we consider all fixed part as a link, and we always give the number 1. So first of all, whenever you see any mechanism, all fixed parts, consider link number 1, and then start by one as a connection goes. Okay, that's it for the kinematic link. Each part of machine which moves relative to some other part is known as a kinematic link or element. Okay, so now let's start types of link. There are basically 3 types of link, and among them first is a rigid link which does not undergo any deformation while transforming the motion. Means if you have seen this, the crank, connecting rod and piston, they are transforming the motion without deformation, but actually there is a no rigid link. Rigid link means there is a no deformation, but actually in every part there is a some minor deformation at some point. It's all depend on the force and stresses. Okay, so in actual condition there is a no any rigid component, there is always some deformation here, but it is a ideal link. Ideally we can say this is a rigid link because it transmits the motion with minor deformation which doesn't affect our motion. Okay, so this is the rigid link. Next is a flexible link which partly deformed in a manner not to affect the, which means it deforms but transmit the motion. It is a flexible. So what are the example of this flexible link? You know any? So check this out. Built rope chain which are flexible, deform but transmit the motion without any losses. Okay, so chain drive, you already know, this is known as a flexible link. They are flexible, but when force is applied, tension can be transmitted throughout these elements. Okay, and third and last type is a fluid link is formed by the fluid and motion is transmitted through the fluid by the pressure. Okay, you know the example like hydraulic press, jacks, hydraulic brakes are there, how they work. Okay, when you apply force, like you apply the force at this point, what will happen? Due to this pressure, force is working on this direction without any solid link. We force apply here at this point and it is transmitted through the fluid. Means hydraulic brakes, you know that. Okay, you apply the brake and due to that pressure, working output we get at that point. Okay, so this is the last link. So this is a fundamentally 3 links: rigid link, flexible link and fluid link. But in our syllabus only we study the rigid link only. Okay, okay, as you seen the types of link: rigid, flexible and fluid. So out of them only rigid link we will study in particular this chapter, because all mechanism which we will going to study are contain only and only rigid links. But there are types of rigid link also. This is the classification of rigid link. So rigid link can be binary link, ternary link and quaternary link. Okay, you can see in this figure, binary link means link connected to 2 other links. Means in this particular link I can connect 2 other links, that's why it is called binary link. And ternary link means if you connect 3 other links to particular one link, then it is called ternary link. And quaternary means you can connect 4 other links. Okay, whatever the position, it is depend upon the mechanism but 4 link can be connected in a quaternary link. So this is the 3 types of rigid link. Okay.